Magma, when it is solid or semi-solid, can be stiff, and for movement it needs some earthquakes. In the Sundhnúka crater chains of the Reykjanes Peninsula of Iceland, at the moment we have a few earthquakes happening at a shallow depth. These are indicators that probably the magma has risen from the reservoir at the depth of the 7 to 4 kilometers, mostly at 5 kilometers. Look at the depth of them. These are from just a few hours ago, and these are the magnitudes of them. They're very tiny earthquakes in that sense. They're not really big tectonic ones. They may be due to the movement of the magma. When the magma faces resistance, you have to break apart its pathway. And the earthquakes actually helps it in a way that like a shaking of a ketchup helps the ketchup to flow. So when such a thing happens, the easiest pathway, which is the cracks or fissures we call, will be a conduit for the magma to reach the surface, eventually erupt. My prediction was that we will have eruption in the 23rd of the February or around that time. And we have to wait and see. There is other view by the Professor Thordarson of the University of Iceland, which says that probably this eruption is over, the tap is closing down, and we may have the eruption even probably 1 month, 2 months from now, and that will be probably the last. At the moment, we have some rain at that area, and as you can see, the steam is rising, the rocks are yet hot. It can be also because the proximity of the magma to the surface is a shallow depth of 1.5 kilometers. I have videos about this in the previous eruptions, and you can watch them and learn about this process. And maybe this time we will have a similar situation. 6.5 million cubic meters of magma has now accumulated and is flown toward the seal that is formed under the Svartsengi. This is the chart of the harmonic tremors. These two dips are a signal that the earthquake storm is going to happen. We see evidence for some bigger earthquakes that are near the surface. And the earthquakes, as usual, moving from the west toward the east. You could see that. And the magnitude is the right amount, 1, 2. These are the amounts that we are seeing here. When we look at the depth of the earthquakes, this is what we see. The depth of the earthquake are at the 5 to 2.5 kilometers, and some of them are at the surface of very shallow depth, 100 meter, 50 meter. You can see, when I turn it around, this diagram, you can see the shape of the dike. Dike is a wall, a crack in the ground, we call it fault line, where the magma is filled up between the cracks, between the pulverized and crushed rocks, and forming this. These are the earthquakes showing the movement of the fault line where the magma can rise there. Magma is present, as I was told, 6.5 million cubic meter is flowing into this area under the Svartsengi and those areas around it. We can illustrate that by this source of the magma to the left, the red part, forming a seal rising at the Svartsengi, and through the seal feeding the dike, which is coming at the near the surface in the graben. We had in the Sundhnúka, Hagafell. Now we will have it in a Hagafell again, north part of the Hagafell, reaching the ground at that level. Between the earthquake storms and this reaching of the ground and eruption is only last time in January was 5 hours, and before that it was 1.5 hours in December. As you can see, here is a close-up of the dike, very similar to what I showed at the depth of the earthquakes. This is the area I believe the eruption happens this time, something between Sundhnúka and Hagafell, north of the Hagafell. Mostly flows toward the south, a little bit toward the north-east, and some of it is slightly toward the north, toward the Svartsengi. Not much of it. The eruption is imminent. We can see it practically. Last time we were in such a situation, just within 2 hours, we had the eruption. I have that video that I made just in that time, and you can watch it after this video. You can compare the chart, tremors charts and everything with the current situation for the eruption in that Hagafell area. Eruption seems as it started. We have the tremors chart showing the sharp rise in the harmonic tremors. The magma line and the tectonic line both have risen sharply. This is like the December 2023 eruption. As you can see, we have a huge number of the earthquakes in the Reykjanes area to the north of the Grindavik to Sundhnúka crater area. We have a similar pattern to what we had also in the past in the December 23 with the tremors and earthquake chart. In this case, the land is yet continuing to rise. But what is interesting is the fat, big earthquakes at the depth shown in this 3D chart. Compared with a few hours ago, there was almost nothing as if. And that shows eruption is near the surface, earthquake, magma, everything is near the surface. At the surface, we see these lights. The weather is not good. We have no good visibility. But any moment we may see something like this, what we are seeing, what we have seen in the Sundhnúka eruption in 2023. This image is from that time. So we are waiting. I'm monitoring the situation. I will report it immediately to you when I see the first light. We have a strange situation in the Svartsengi volcanic system. Although the volume of the magma available, according to our measurements of by the GPS data, shows that the threshold, the lower threshold from the previous eruption is now surpassed for the current eruption. But the amount of the uplift is almost half of it was in the previous last eruption in the November 2024. So what we are seeing now is around this line, and what we were seeing previously in the previous eruption was almost double that. That may mean, in one way we can interpret it, is that in the previous eruption, the shape of the magma reservoir available was more concentrated and lobate, rounded, like a balloon, inflating the land higher. At this time, it has spread more in a larger area, and the amount of the uplift that our GPS shows is almost a half. That can be one explanation. Another thing is that we don't have enough earthquakes. The amount of the earthquakes now we have is not enough, and they are in the wrong place. Look at it. Svartsengi volcanic system doesn't have enough earthquakes, but more earthquakes we have in the Krýsuvík and the adjacent volcanic system to the east. I'll play that again for you. What that shows is also that the earthquakes needed to actually shaken up like a catch-up, the magma, open up the way for eruption. They are not there. The magma cannot erupt. Also, recently, Professor Thorvaldsson Thordarson has shown that the information which he has from the boreholes shows that the water and hot gas production at the stops in the boreholes that they had in the Svartsengi volcanic system. So that may mean that adjacent volcanic system, Krýsuvík, maybe is more prone to be actually erupting next. As we know that this volcanic system exists there for a reason, they have been erupting consequently, one after another, in geological terms, almost like a snap. We have to wait until the 23rd of February just to see, this is my prediction, if it erupts or not. If it doesn't erupt, it may actually have shifted toward the Krýsuvík. The earthquakes are now the right amount, and we have evidence for the magma reservoir building up in that area. I have a video about that. Watch that. Explains. Since the end of the last eruption of the Svartsengi volcanic system in August, we are seeing lots of earthquakes in the area of the Reykjanes Peninsula of Iceland. Many of them are concentrated around this lake, which we call Clairfawvatn. And that is forming along a series of the transform and extension faults that divide the boundary between the Eurasia and North America. The pulling apart of the land in this area create this extension and transferring the movement to those transform faults, the top parts at a shallower angle. And most of it at the moment are concentrated in the Krýsuvík area. And we can see in the depth model of this earthquakes, they're concentrated around the depth of the 7 to 5 or 4 kilometers. This is the area earthquakes are happening. Earthquakes are practically shatter or fracture zones, creating voids and fractures and pulverizing rocks, creating pathways practically for any kind of fluid that can flow there. It can be water, brine, or even magma. In this case, in this area, if you have a magma reservoir at the depth of the 12 kilometer, which is in the case in the Svartsengi, that can feed these shallower reservoirs, which are formed by these earthquakes, and create a shallow magma reservoir. We have it in the Svartsengi volcanic system, where this shallower reservoir, like an aquifer, fills up and every now and then erupts as a volcano in this area, as a fissure eruption, actually, I should say. For example, in the Svartsengi, we had it in the Fegedesfjall. This is happening for the last 3 years, and we are seeing it here. There is a possibility we are seeing formation of this kind of reservoir for the magma, pulverized and fractured zone at a depth that can form a reservoir in the Kristofik area. This area is, of course, a volcanic system. Already we had eruption there, and there are lava fields associated to that, which extend for 50 kilometers, even approaching the town of the Reykjavik, the capital of the Iceland. This is a cartoon which shows what I have talked about in this area. And the extension, as we know, is happening in this fashion, that one eruption in one area, for example here, as you see in the lava flow marked, that's, for example, Svartsengi, eventually will lead to eruption in the adjacent area, which is this purple area in this map, and create another volcanic system. The Svartsengi may cease to erupt, but the Kristofik eventually will start and take over. As the eruption gets more difficult in the Svartsengi, Kristofik, building its reservoir, will be the next one to erupt. It may happen anytime next year, within 2-3 years, if we are lucky to witness this, or we should say we are unlucky. At the moment, we are seeing the building up of the magma reservoir without actually magma being inside it. This is just a reservoir, meaning a shattered zone of fractures, like the aquifers for water, where any liquid can actually gather in that area. And we are waiting for that just to see what happens. I have a video about the situation and what is going to happen in this area, or what is happening, I should say. Please watch that also, which complements what I've said here. We have a series of earthquakes, about 17 of them, concentrated in a small area in the Reykjanes Peninsula of Iceland, around the lake Clearwater. And as you can see here, the timing was interesting just a few minutes ago, and the concentration of them in a certain time. And that was it. When we look at the data closely, we see the depth of them is interesting. I have marked them here. You can see the depth of the 5 to 7 kilometers, and the magnitude is written here. They're quite small. And when we plot them on a chart in 3 dimensions, you can see that they are restricted to a depth of the 7 to 5 kilometers, magnitude relatively bigger compared to what we have in this area. And in that area, we don't have any earthquakes at the moment that is as big as that. Although we have the Svartsengi swarm rising gradually in the middle, you can see that. And the location of them indicates these are related to the Kristofik volcanic system, a nasty big volcanic system. When the movement in this peninsula happens, the Kristofik and the adjacent volcanic systems, there are fault lines, they have to accommodate this. Through the transform faults, as you see here, and this is the jagged line of the transform fault and the normal faults. Transform faults are those ones in the black. I've marked them, the movements of them in the Eurasia and the North America. Eurasia is toward the right. When they pull apart like that, the earthquake happens. And this is the exact definition of this kind of, rupture. When such a thing happens deep in the earth, these blocks of the rock, these slivers of the rock, down to the mantle of the earth, softened at the depth, of course, create these sudden jerky movements. We know they are not related to the magma movement, because when we look at the GPS data for this area, this is Kristofik data, you cannot see any change in the GPS data due to the accumulation and rising of the ground due to the accumulation of the magma. Adjacent station also doesn't show anything like that. These are the definition of the word tectonic, and this is what we see here. Sudden, jerky movement which creates rupture and breaking apart of the earth crust. That is tectonic. This is the definition of the rupture, breaking or bursting suddenly. And this is the AI image created when you describe it. Such a thing, something like that. Of course, at the depth, no gap between them. But that is a tectonic rupture of the Kristofik to accommodate the movement for the peninsula.